Hi everyone. We're gonna show in this video how to update a device using Azure Device Update on top of the Azure IoT Middleware for FreeRTOS. And we're gonna be using the ESP32 today to show that. And with that, you're gonna be able to do remote update of your own device. So let's start by going into the sample folder that we're going to be exploring.
This repository is a repository that's dedicated just for the samples over the Azure IoT middleware for FreeRTOS. There is a separate repo just for that middleware itself, which you can find referenced in the main README of this repo we're seeing here. And this is a sample that is specific for Azure Device Update on top of ESP32. And here you'll find a guide containing all the details necessary to go from zero to device fully working and being able to be remotely updated. And we're going to start by installing the prerequisites. And the first one is going to be Git, which you can get directly from the official website. And now that that is done, the next one is ESPRESSIF's ESP-IDF. And we've tested here according to the documentation with the latest as of now, which is the version 4.4.3. It took about 10 minutes or so to install the SPIDF. It's quite a while, and now we're gonna just check to see if everything is fine here by checking the version. Perfect. And now we're gonna move on with the next prerequisite in the list. We already have PowerShell installed because we're running this on Windows and it comes with it. So the next thing to install is Azure CLI and the IoT module that is going to give us the ADU commands. Looks like I already had the Azure IoT module installed from before, so we're good here. Now we're done here, and next we're gonna clone the Azure IoT middleware for FreeRTOS samples repository and configure the ESP-IDF environment. Now we're going to go to our IoT Hub and we're going to create a brand new device for this sample test. do a step for Azure Device Update to recognize the device as an updatable device. And that is called tagging. And that tag is added to the device twin document. Note that the name of the tag can be anything you would like to be. So it's basically just the name of the update group that this device is going to be part of. Many device IDs can have the same group name, and that's how you group devices for deployments. Well, now we're going to have this part, which is where we configure our sample to specify what is going to be the IoT hub that the sample is going to be connecting to, which device ID is going to use, and the credential, the primary key for the authentication. For the expressive expressive samples use kconfig as the default way of configuring. So we're going to launch the menu config here in a second. This is also where you specify the SSID and password to the Wi-Fi that the device will connect to. And just as a reminder, for the ESP32, you need to have a 2.4 gigahertz Wi-Fi connection. Next, we're gonna proceed with building the sample code. And it's important for us to understand what is going to be what are the steps coming ahead of us here. So we are flashing the device with a version that is a 1.0 version of the image, and we will then let it run, and then we will create another image, this time an image that has a version 1.1. And that is the image that we're going to pass along to the Azure Device Update service. And that will deliver the image to the device for the over-the-air update to happen. So the first thing we're going to do is to build the 1.0 image, and then we're going to make some changes so we can produce the 1.1 image. Now that image 1.0 build is complete, we're going to flash it to the device. I just connected the ESP32 to my computer. So the next thing that I want to see is what is the COM port that it's connected to. And I can see it's COM5. And that's what we're going to use in this command from the ESP-IDF that flashes to the device. I'm also using an additional option here, which is to start monitoring the serial output of the device right after flashing is completed. We're going to leave this instance of the ESP-IDF attached to the device, monitoring the serial output. The device is waiting now for the Wi-Fi to become available, and I'm going to use a hotspot directly from my Windows machine. And finally, the device connects to the Wi-Fi, and right away we can see that this is the version 1.0 image running on our device. Then next is when we actually create the Azure Device Update service and associate it with our Azure IoT Hub. You can find more details about Azure Device Update through the links that we have in that documentation that we're following. Just be aware that it will take a little more than 10 minutes for the ADU service to be created. And now that that is done, we can proceed with this next step, which is to build the version 1.1 of our device image. Pay attention here to the detail that we will need a new ESP-IDF instance for that, so we have a clean environment. And to make this next build version 1.1, we need to change a define in the sample stating that it's now version 1.1. And now we just need to build the sample again with this new version and save the binary file. We are copying the binary file to a different folder just to keep things clean. The next step now is to generate one of the important parts of the Azure Device Update architecture, which is the update manifest, which is a document that will describe this update, including what files should be downloaded by the device and several other details. Once these files are generated, now we need to upload them to the Azure Device Update system. It takes a few minutes for a new update to be validated by the Azure Device Update service. As you can see now, we have here a group that we can deploy an update to. And the name of this group matches that same tag that we added to the device twin. And the final step here on the UI is just to deploy the update. Once the Azure Device Update service updates the device twin of our device with the update request, that is then received by the device and it starts processing. It's going to do a validation of that update request, and then it's going to start downloading the image from the container where we have saved it. The SHA validation of the file takes about 2 minutes. And once the update is complete, the device resets as it has been implemented in our sample. And as you can see, right away, it shows that it's on version 1.1 now, which is the image that came over the air. It then receives the same update request again because the device tree has not been updated yet, but the request is rejected because the device knows that that image is already deployed. Here in the UI, you can see now that the device has been updated and it's up to date with the latest version. And that's how you perform an update of a ESP32 device with Azure Middleware for FreeRTOS and Azure Device Update. Thank you for watching this video. We hope you find all the information you need to try Azure Device Update over-the-air updates by yourself with your own devices. Please leave your comments and any suggestions for improvements, as we'd like this documentation to be as concise and complete as possible. Thank you very much.